Okay, so let's do these computations. So basically what we're saying, for this one, if we translate x, if we translate f, a units to the right in the x domain, in the space domain, what happens in the frequency domain or the Fourier transform domain? So that's what we're doing here. So g hat, again, the strategy is always going to be to pretty much just start with the definition. This is the integral from minus infinity to positive infinity, f of x minus a, e to the minus I cx dx. Okay, so I want to get this in terms of the Fourier transform of f. So it means I don't need an x minus a in the argument to f. I just need the variable that we're integrating with respect to. So I'm going to say u. I'm going to do a u substitution, a little change of variables. U is going to be equal to x minus a. Du is going to be equal to dx. Okay, when we change the limits of integration, infinity minus a is still infinity, minus a is still minus infinity. So the limits on the integration are going to stay the same. We're going to have f of u here. Okay, what's going to happen with this exponential? If u is equal to x minus a, this means x is equal to u plus a. So whoops, don't need to write the e again. So this is e to the minus I c, and then x is u plus a. Okay, but now I can split this exponential into two pieces, and I can pull one of them out, because what's going to happen, I'm not going to rewrite this whole thing. Well, maybe I will have to. I'll just stop being lazy. So this is going to be the integral from minus infinity to positive infinity, f of u, e to the minus I cu, e to the minus I ca du. Now, as far as u is concerned, this is a constant, and we can pull this out. And what we end up with is this. Okay, but this is just the integral here is just the Fourier transform of f. So this is now e to the minus I ca f hat of c. Whoops, and there we go. Okay, so now we're going to do something similar over here. If I want to compute the Fourier transform, g hat, just again go directly to the computation. This is going to be the integral minus infinity to positive infinity, 1 over a, f of x over a, e to the minus I cx dx. Similar to above, I want to get this in terms of the Fourier transform of f. So it means I don't want the argument to f to be x over a. I want it to be whatever the variable is we're integrating. So I'm going to make a similar change of variables. U is going to be equal to x over a. So du then is going to be dx over a. I'm going to make my changes. Again, if x is equal to infinity and u is equal to x over a, then infinity over a is still going to be infinity. So the limits on the integrals will remain the same. I'm going to move this 1 over a out. Okay, now this tells me dx is equal to a du. So I'm going to have minus infinity to positive infinity, f of u. I'll change the differential in just a second. Okay, so if u is equal to x over a, then x is equal to u times a. So this is now e to the minus I c u a, and then dx is equal to a du. Okay, so we can see the a's are going to cancel. And now I'm going to write this in this way, minus infinity to positive infinity, f of u, e to the minus I ca u du. But notice what this is. This is just like the Fourier transform, but now instead of c being the variable we're evaluating the Fourier transform at, it's c times a. So this is just f hat of ca. F hat of ca. And there we go. And so that's the Fourier transform for this function. What do we have on the next? Okay, so we'll stop there and go on. Well, actually, no, okay, yeah. Let's stop there, and then we'll do the next one for the other videos.